Now what we will do is, to give you a practical example, we will model a simple frame in STAAD.Pro. We will model first a standard frame and check its weight. Then for the same frame, we will change it with a PEB frame. And we will see the comparison between the two frames. Okay. Now we will start with STAAD. Okay, so this is the STAAD.Pro Connect Edition, latest version. Okay, so when you open this, you see this kind of interface. Okay, so this is the first screen which appears when you open STAAD.Pro. Now I want to open the new model. Okay, I will say new. Then I will have to give name to my model. I will say comparison PEB conventional. We can save it. In the units, I will always choose matrix, because matrix in English, if we choose English, we get the units in feet, inches, but I want the unit in meter, centimeter, kilonewton. So I will choose metric. If you are working for any American structure, then you can choose the English. And in that case, you can use the units like feet, pounds, inches. Okay, so now I have given the name, chosen the location, say metric, say create. Okay, I need to mute the mics. If anyone has any doubt, you can unmute and ask me. So this is the screen which will appear to you when you open STAAD.Pro Connect Edition. Okay, now we will start. So now this is the screen. We will start with the modeling of a simple frame. Here in my right corner, you can see nodes where we can add node. So first node we will mark at 0, 0, 0. So you can see this is one of the node which I have created. Now I will select this node with the help of, when I go in select, I have here node cursor. I click on node cursor and I choose this node. Now I want to copy and paste this node as per my requirement. So I'll say Control C, Control V. I want the height of my structure to be 3.5 meters. We are now just creating a simple frame to understand the difference between conventional and standard and PEB structure. Okay, so my height is 3.5 meter. And now I want my roof inclination to be of 0.5 meters. So why it will be 0.5, and I want my total width of the frame to be 8 meters. So this will be half, 4 meters. Say okay. Here I can go in view and choose the front view. Okay. Now I will copy these 2 points, Control C, Control V, and I'll paste it at 8 distance apart, 8 meter apart. So now we have created this point. I will connect them. I'll choose add a beam and I will connect these points. Okay, so we have modeled just a simple frame. Geometry is done. Now I want to assign properties to this frame. I'll go in properties. Here I will say section database. First case, I want to apply the standard properties, standard sections which are available in the market, the conventional sections. So I'll go in section database. When we go in section database, here we can see a lot of profiles as per every country. So I want to choose the Indian section. So I'll go in Indian. Here also I have many sections. I want ISMB 250. So I will click on S shape. Here I will search for ISMB 250. I can see it over here. I'll say add. Okay. I want the same profile for the rafter. So I'll add it twice. Then I'll close it. Now we want to assign these sections. You can see section 1 ISMB 250. Now I'll choose my columns. I'll press Control button and I'll choose both the columns. I have chosen this first ISMB 250. At the bottom, it is written assign to selected beams. Say assign. Yes. Now these two members have been assigned with ISMB 250. Now I will assign the rafters with the second one. ISMB 250, assign to selected beam, say assign, yes. Okay, we are done with the geometry. I assigned the properties. Material is also assigned. It is the steel. Specification, I don't want to give any particular specification right now, so I don't want to change it. Support. In this case, I want to give a simply supported pin connection. I'll say add support, use cursor to assign. I'll say assign. I'll choose both my nodes. Say escape. Now I have assigned the support. Next part is the loading. I'll click on loading, load case detail. I'll click on the second option, load case detail. I will say add. Load case 1, none, that is fine. We just want to apply some load and check load case 1. Again, I'll click on load case 1 and I'll say add. Now I'll go in member load. I want to apply a 15 kilonewton meter of UDL, uniformly distributed force, on my member in direction GY. I will say add. Then we can close this. Right now you can see uniform UDL GY of value minus 15 kilonewton, means downward. It is saying question mark right now because we have given it the input over here, but we haven't applied it on our system. So I'll click on this. I'll say use cursor to assign. Say assign. I'll click on both my rafters. So you can see now load is being applied on both of my rafters. Then I'll say analysis. Define command. Perform analysis, no print. Say add. Close it. Last is design. Click on design. Here you can see you have to choose the code, with which code you want to design. So I'll choose, click on that. I will choose IS 800 2007 LSD. So I want to define it. I want to define my members. I want to design my members with the code IS 800 2007 with the limit state method. You can here click on assign to view because we want this to be applied on our whole system. Say command, check code, add, and take off. We also want to see how much tail we are using. See, click on take off, say add. Now you can see in parameter 1, we have the code IS 800, check code is question mark. So I'll click on assign to view, say assign, yes. So my whole system is chosen and it will be checked according to the code IS 800. Same I will do for steel takeoff. Assign to view, assign, yes. Okay, so I will run this analysis. Say save. You can see we are getting 0 errors, but there is one warning. Right now I'll say done. I want to check what is the warning. So I will go in utilities. At the top you have utilities. Here you have command file. I'll click on command file. When I click on command file, this command editor, this STAAD editor will open. And here at the first line, you can see it's written STAAD space. Means the STAAD model is designing my frame in 3D view as a 3D structure. But my frame right now, I want to only analyze it as a 2D structure. So I will delete this space and I will write plane. So if I write STAAD plane, it will analyze my structure as a 2D structure. I'll say save. I'll close this. Now again, I'll go in analysis and design. Again, I'll say run analysis. This time I am getting 0 errors and 0 warning. That is fine. Again, I'll go in view. I want to see this in the front view. I'll click on front view. Now I have done my analysis. I have done my design. I will go in post processing. So this all process we did in analytical modeling. Now I want to see in post processing what is the answer, what is the design value. So click on post processing. Which load you want to check? Load case 1. Say OK. So here you can see some displacement. Right now I'm interested only in the utilization ratio. So here in the results you have the option for utilization ratio. I'll click on this. you can see all of my members are maximum utilized. They are utilized up to 97%. Column utilized up to 97.7%, and my rafter is utilized for 99.4%. Okay, and now I want to check what is the weight of material which I am needing to for this frame. So I'll go in utilities. Here I have analysis output. I should click on analysis output, and we get this file. Here when I click on steel takeoff, I'll double click on this. Here you can see my total length of member is 15.6 meter, but I'm interested in weight. Right now you can see the weight is 5.5 kilonewton. Okay, 5.5 kilonewton. We have to keep this as in mind. So I'll take a screenshot. Okay, so when I use my standard section, my weight is 5.5 kilonewton. Now what I will do, I will go back to analytical modeling. I'll click on properties. Previously, right now I have given this ISMB 250, but now I want to give it pre-engineered building. So I'll delete this. Okay, delete, say okay. But now before giving it a tapered section, I want to check how is my bending moment diagram. Again, I'll have to go in analysis, save yes. Okay, there is no section assigned. Okay, just a minute. We did one mistake. I'll choose this Indian code. Before deleting this, again, I will assign ISMB 250. I'll choose both my columns. I'll assign ISMB 250. I'll choose both my rafters and I'll assign the second one, ISMB 250. Run analysis. Okay, still we are getting some error. Elastic modulus. I don't know why we are getting, we have given it steel. There is some error with my STAAD, it automatically closed. I'll just open it again. Okay, Arun, if you want to ask anything, you can ask. You have raised your hand.
Sir, why we choose the I sections?
Right now, we are having a comparison between the standard sections and the PEB sections. So first, we are analyzing this frame with standard section. So I have chosen I section. And we have seen the weight of this section is 5.5 kilonewton. Now, next time I want to analyze this same section with PEB section, and we will compare the weight and see how much weight is reduced. So first we are doing it with conventional section. So I have chosen I section. Okay, I'll analyze it. Oh yeah, I'm getting some error. Okay, just let me create a new one really quick. Is your doubt clear?
You better change the location of your file. Actually, sometimes ago I was also getting the same kind of error, and later I changed my file path.
Location.
Then it
Yeah.
got actually corrected. Like
Okay, because sometimes many files are created with
yes,
almost
yes,
similar
yes, yes.
name.
It got
So
confused
yeah,
actually.
it gets confused. So I have
Yes, yes.
chosen, I've changed the location slightly.
Yeah, that is
Okay.
fine. Then I
Now I'll
think.
create another program is creating the model. Are you sure you want to exit? Okay,
सर
just a minute.
may I say something? I am एहसान सौदागर.
Yes, yes.
सर आप क्या कीजिए उसको हमने जैसा कि मटेरियल में उसको स्टील प्रोवाइड किया है ना
हाँ, हाँ.
मटेरियल प्रोवाइड करके वापस से स्टील कीजिए सर, मेरे साथ भी होता है ऐसा कई बार।
हाँ वैसे मैंने किया था, आई जस्ट चेक इट अगेन। हाँ
मटेरियल चेंज करके वापस कीजिए सर। हाँ जी, थैंक यू
ओके
सर।
ओके, सो लेट्स ट्राई इन दैट वे। आई असाइन द मटेरियल अगेन। व्यू में जाके आई सी इट इन द फ्रंट व्यू। यस, in the material I have the steel. I'll say assign to view, assign, yes. Properties we have already given it, yes. Other all things are fine. Now it should work.
मटेरियल में कुछ नहीं आया है, देखिए ना आप सामने।
किसमें?
मटेरियल स्टील के सामने मटेरियल में, सॉरी सेक्शन के सामने मटेरियल में कुछ आना चाहिए ना।
या व्हेन आई क्लिक ऑन प्रॉपर्टीज, यहाँ पर मटेरियल में
कुछ भी नहीं है, तो वापस से एक बार असाइन कीजिए।
ओके मटेरियल
स्टील।
but still I have chosen assign to view, assign, yes. प्रॉपर्टीज में अभी भी नहीं आ रहा है।
डबल क्लिक कीजिए सर उसके ऊपर।
यहाँ पर तो लिखा है मटेरियल, सो
स्टील पे क्लिक कीजिए सर, मटेरियल के नीचे वाला। कोई और कीजिए, फिर वापस स्टील कीजिए।
आई एम चूजिंग
कीजिए
कंक्रीट।
पहले। वापस से स्टील कीजिए,
स्टिल
नीचे चेंज कीजिए।
चेंज का ऑप्शन नहीं आ रहा है या okay, so it is better कि I'll create a new file that will be faster
ओके ओके।
because
think that will be
ये
better. Instead of wasting
yeah
time like this, now we can create a new file.
because this is my, we have this cracked version, so there is always some error in this. So I've chosen metric. I'll say create. Okay, comparison. So I'll now just go quickly. Y is 3.5 meter. I'll choose both these points. X is my 8 meters. Then in the view, I want to see it in the front view. I'll choose this point. My X is 4 meters at the center. Y is 0.5 meters. I want 0.5 inclination. I'll go in geometry. I'll say add beam. From the bottom, I'll add the beam. From the left to the right. Here also I'll go from bottom, from right to the left. I'll go in properties, section database. I'll choose Indian ISMB 250, add. For right now, I'll choose only one because I have same. Assign to selected beam. Yes, now steel is visible, so I won't get any error this time. Here also it's steel already. Support, I'll create a pin support. I'll say add, use cursor to assign. I'll go in loading, load case detail. I'll just say add.
Sir, why you not provide the fixed support, sir?
Because right now we want to just model this 2D frame. We can also go with fixed support, but in pin support, we will get for 2D it will be better because we want zero moment at the bottom right now to understand this case. So
Okay.
I'm going with pin. We can also go with fix.
Okay.
To show you the difference between the standard section and the PEB section, I want zero moment at the bottom. That's why. Okay. First, we will choose Indian code IS 800 LSD. Check code, add, take off, add. Now check code we will assign to view. Still take off we will assign to view. Yes. Now I just need to go in the command and change the space to plain. Oh yeah, some again I got some error. I hope it doesn't close. So, yeah. Just let me run this. Okay, so I got 0 errors, 0 warning. Now I'll go in post processing. I'll say okay. We will check the utilization. It is 99, 97. Now I wanted to check the bending moment. Okay, in the view, I will see it in front view. You can see this bending moment, the typical bending moment which we get in a frame. At the bottom it is 0 because we have pin support. If we use fixed support over here, we will also get some movement over here. So right now we are taking pin support. At the bottom it is 0, and at the connection between rafter and column we have some maximum bending moment. Again at this point, when I choose my rafter, I double click on my rafter. You can see at a distance of 1.25, my bending moment is 0, and again my bending moment increases to 51 at this other end. So what I will do is, from here to somewhere between here, between my 0 moment, I will break. Okay, Shivam, you have any doubt?
Yes, sir. But in actual, there how we provide fixed support, sir?
In actual, how we provide fixed support, there is a
Yes,
connection between the column and the footing, the base plate
sir.
and the column.
But we provide bolts, no, sir. So it's
Yes.
also fixed. And sir, in actual, sir, is there any pin support for
In actual also the pin support is possible. Many of them have the same query that in actual we cannot provide pin support because we are
yes,
giving bolted connection. But that
yes,
is
sir.
possible, and I will be explaining you that when we go in our real time project. Okay,
Okay, sir.
so
Okay, sir.
this question will be answered, but in a short while.
Okay, sir.
Yeah.
Okay, sir.
Sir, one dot, sir.
Yes, yes.
Sir, why FY value is not given, sir?
Fy value.
Yes, sir.
Right now we are going just with the whatever is by default given by the system, because we just want to analyze it and we want to see the comparison between the PEB and conventional. When we go to our main model, we will give it all the design parameters. This Fy, Fu, these all parameters comes under design parameter. So this
Okay,
we
sir.
will be giving later. Right now we just want to analyze and see the difference between the frame. That's why.
Okay, okay, sir. Thank you, sir. Thank you.
Okay. So quickly I'll show you. Previously we had this 5.5 kilonewton load. Now what I will do is I'll go back to analytical. In the properties, first I will break this member. I choose the member, I'll right click on it. I'll say insert node. I want to insert node at a distance of 1.4, just somewhere between the point where I have my. So see, now it is broken. This and this two are separate. So now what I'll do, I'll delete this. Okay, if I'll get again some error, so I'll keep it right now like this. If I want to give pre-engineered building PEB sections, so we don't go in section database, we go in define. So now we want to give it a PEB section. So we'll click on define. I want to give a tapered I section. I want to give I section in which the depth goes on changing along the length. So here in this figure, you can see F1, where my node will start. At that point, what I want to give depth of the section. So my node is starting at the bottom. At the bottom, I will give 0.1 meter. This thickness of web, I will assume it as 8 mm. I want to give 8 mm thickness of web. Depth at the end. I want to start my column with 100 mm and I want to end my column with 300 mm. I'll give 0.3. Width of the flange, I want to give my width of the flange as 140 mm. So I'll write 0.14. Thickness, I will give thickness of flange as 10 mm. So 0.10. So I will explain you once again what I have written over here. F1 is the depth of the section at the start of the node. When my section will start, I want my depth of the section, means depth of the web, to be 100 mm. So I have written 0.1. Thickness of web, I want 8 mm. Depth of web at the end of the node, I want 300 mm. So I've increased from 100 to 300. So from bottom it will be 100. At top it will be 300. I want my flange width to be 140. I want thickness of flange to be 10. This two, if we write 0, it will assume the same values as we have given for the top. So right now I don't want to change my top flange and bottom flange. So I want same. I will say add. This I have added for column. Similarly, I want to add for my rafter. So for my rafter, I want to start it with 280 and I want to end it with 100. And I want to give the width as 100, width of my top flange. Okay, I'll say add the other rafter. So this rafter again I'll have to change. I will start it with
F6 और F7 का वैल्यू नहीं डालेंगे क्या?
F6 और F7 का हम वैल्यू अगर नहीं डालते तो वो एज्यूम करता है कि हमारा टॉप और बॉटम फ्लैंज सेम है। तो अभी हमारे केस में हमें सेम चाहिए, तो हम ये 0 डालेंगे तो वो सेम लेगा, 0.1 और 0.01 ले लेगा। Okay, so if we don't mention any value in the F6 and F7, it will consider that top and bottom flange is same. That is what we want.
The uniform thickness should be there for a flange from the bottom to the top, sir. That may be the reason.
Yes.
Practical problem, that is because we cannot keep different thicknesses for entire length of the section.
Yes. Yes. Okay, so for other I want to start with 0.1 and I want to end it with 200. Okay. Width of flange will be 100. I'll say add. So now we have written 3 type of tapered beams. This tapered beam is for my column. So I'll choose both my columns. Tapered section is chosen. I will say assign to selected beam. Say assign. Yes. Now these 2 sections have been assigned. Okay.
Sir, instead of tapered, why can't we take another sections? I mean, built-up sections.
Built-up sections is also possible, but right now we are comparing I section, standard I section with tapered I section. Okay, so now the third tapered profile, I will assign it with these 2. Say assign, yes. And this I will assign with my 4th one. Okay, now let's see how it looks. I will go in geometry.
Sir,
3D render view, yes.
how we can decide the size of these members?
This size, you can see where we have maximum bending moment, we have to give maximum shape, but this will depend on trial and error. First, you have to give it, you have to run it, you have to see what is the utilization, and to get the maximum utilization, you have to do trial and error. But the basic concept is where you have minimum bending moment, there you can give minimum depth, and where you have maximum bending moment, there you can give maximum depth. This section, how to choose the section, that will depend on the load which is coming, and that will depend on trial and error method. See, this is the profile which we are getting right now. Okay, so let's analyze this one. Other all properties are same. Let's analyze and see. Okay, we are getting 0 errors, 0 warnings. And now I'll go in post processing. I'll check my utilization. See, now utilization is, this is 98%, this is 95%, but this is slightly failing, 1.1. So I have decided it that I want to start it with 100 and I want to end it with 200, but it is slightly failing. So what I can do is I can slightly increase it. So this is what we do. Instead of 200, I'll make it as 220. Okay, we'll run it again. Okay, now you can see the utilization is 96, 93, and 98. Now let's see what is the weight of this member. To check the weight, we will go in utility, analysis report, analysis output. I'll double click on this. Now you can see the weight is 4.26. Initially for standard section, the weight was 5.5. From 5.5, we have reduced the weight to 4.26. So this is the advantage. In this case also, the conventional case, which first we did, in that case also, the utilization was above 95. And now when we are tapering the section, again, the utilization is around 95, but we have reduced the weight drastically up to 25%. So this is the advantage of PEB sections. Right now we have considered tapered I section. Okay, so this is what I wanted to just show you.
Welcome you all in ISO certified live training program, ETABS, RCDC and Excel that makes you a professional structural engineer. In this training program, you will learn everything about ETABS and RCDC from basic to advanced, real life project of medium rise structure from architecture plan to final design sheet, real life project of high rise structure with all advanced topics, design of structural elements using advanced Excel sheets. Have a look over the features of this training. Daily live classes conducted by expert for 1.5 hours. Recording of every session with lifetime access. Can interact with expert anytime, 24/7. Exposure to real practice. ISO certification of training completion. It's 5-star rated training program. Till now, more than 1,000 participants have benefited from this training program. Now you are the next. Hello everyone, welcome you all in a new ISO certified live training program, design of substructure using CSI Safe, Excel and manual. In this training program, you will learn all about the concept of substructure design, commands in CSI Safe software for the substructure design, validation of CSI Safe result with your manual and advanced Excel sheets. This training program will cover 4 real life projects. In the first and second, we will cover all the types of isolated foundation in CSI Safe software. In the third real life project, we will cover the raft foundation. And in the fourth real life project, there will be the coverage of pile and pile cap design, design of basement wall. And at the end of this training program, you will learn how to prepare the final design sheet for the site execution. Have a look over the features of this training. Daily live classes conducted by expert. Recording of every session. Can interact with expert anytime. Exposure to real practice. ISO certification of training. It's 5-star rated training program. Till now, more than 1,000 participants have benefited from this training program. Now you are the next.